This conference will now be recorded.
The dimension table which contains unrelated data or any unwanted information. Such table or columns are considered as a junk. Actually, in the transformation process, what they will do the transformation as per a data warehouse requirement. Data warehouse requirement. So in data warehouse, what is the structure? Accordingly, they load the data. So in the source, what is the source? OLTP systems. So OLTP is nothing but it is also a database. They might be use text text files, Excel files, whatever it is. So any type of data source which stores current business information will be OLTP. So as part of the process, when they are fetching data, when they are extracting data from various source systems, the source format may not be accurate as per data warehouse requirement. Moreover, source format is not always the same in all the OLTP systems. So they have to do transformation. As part of the transformation, they might find invalid characters. Okay, so they might find uh, some unwanted spaces or whatever it is. So whatever the junk they identify, they'll store it into the one other table so that it will be useful for auditable information, like what type of unwanted information getting stored in from which source system it is coming, and how to rectify, how to resolve that issue to store it into the OLTP systems. Such level of identification can be done using junk dimensions. So as part of the transformation, whatever junk identified, that get stored into the junk dimension, later it get deleted. Junk means it's complete unwanted unrelated information. There is no relation with any other table for this junk dimension. Another one is a G degenerated dimension. Okay. So as part of the transaction, the data gets stored into this dimension table. Okay, so this is only the dimension. This is the dimension table stored or having primary key. What is the purpose of primary key? Actually, for valid dimension tables created with the primary keys. If you look at any of the dimension table which will have a primary keys, but this is only the dimension table having primary key without any data by default. I mean, there is no textual information. So the data gets stored as part of the transaction. Later it get decommissioned. The data get generated as part of the transaction. Okay. Later it get decommissioned. It get deleted. So moreover, where this degenerated dimension exists, it is existed in the transaction level. It is existed at a transaction level. So for example, we are doing transformation. We are now loading data into data warehouse. So when the transactions are happening, when the data getting loaded, so I have created one degenerated dimension which is going to return one or zero characters. Okay, so it is going to store numeric information. So when it is storing as part of the transaction, so you can take any reference, it is part of the transformation. I mean, as part of the transformation, when you're loading data into the data warehouse, you can take it up. Otherwise, in a business, when a successful transaction made or when a transaction made in the business, the information, the flag information gets stored into the degenerated. Flag means what? So what is the identifier, 1 or 0? Otherwise, let's take true or false. Okay, so what is another one? Yes or no? Okay, so these information get stored as part of the transactions made in the business. As part of the transformations loading into the warehouses also, they'll create a table, they'll store that transformation information into this degenerated dimension. Transformation information means what? If the transaction is successful, this table returns 1. So why 1? Or you can take any reference, yes or no, or true or false. So when this table returns 1, they'll execute some more script. Got it? It is just an example. So when this table returning 1, it runs one script. When it is returning 0, they'll run another script. Okay, so it is going to store a numeric. So in the warehouse we discussed, right? So in 99% cases, fact information is the numeric information will be the fact, but there is few tables which stores which considered as in 1% case textual information. If you take yes, true or false, this will be text information, but that will be considered as a transaction table. This is only the table which stores which acts as a fact table. Got it? So how ETL team is utilizing this type of table is matters based on the requirement, based on the late data loads. So when you take a transaction in the business, original transaction level, how the transactions are happening, how they are finding what is a successful, what is a failure, such level information captured into the degenerated. By default, the data in the degenerated dimension is empty. Based on a transaction, the data gets stored, because once it is successful, they'll run another script. If the transaction is failure, based on that another script, the second script get executed from the ETL end or from the transaction level end. Okay, so this is a one dimension table which acts as a transaction table. This is one dimension table, dimension table considered as a fact table. One more thing, this is one dimension table not having relevant or related dimension tables. Why? Because maybe that is in other machine. But so as you know, we have the dimensions star schema and the snowflake schema, right? So when you are having a star and snowflake, what is happening? There is a direct relation between two dimension tables. I mean, in the snowflake, there is a direct relation between two dimension tables. So in the star schema also, the dimension table related with the fact table, correct? So maybe this dimension table acts as a factor, but it is not having relevant dimension table because it is not having textual information. I mean, it is not having business level information. It is not having customer information, not having product information, not having geographical information, not having any date information. Okay, it is generated based on the transaction. By default, it is empty. That's the reason this is only the dimension table acts as a fact table. But the thing, there is no relevant dimension table for this dimension. By default, data in the dimension is 0, and the data gets stored as part of the transactions made in the business. Okay, later it get decommission because by default it is 0 records. So there is one more dimension table, that is inferred dimension. So there are few empty dimensions get created in the warehouses, get created in warehouse. So such a type of dimension tables are inferred dimensions. Moreover, there is no, this is the tables, there is no primary keys defined on this table, and also no textual information. So a complete dimension table means what? Primary key has to be defined and it has to store textual information. So it is against to that. So there is no primary key, there is no textual information. It is just a dummy dimension table. It's empty dimension table. So based on the future references, they will create n number of dimension tables. So whatever not being utilized till now, those will be considered as inferred dimensions. It has a number of columns. There might be a structure, but there is no primary key, there is no data into that. That is complete empty. Okay, so such type of dimension tables are inferred dimensions. So let's discuss about measures. So whatever as of now we have discussed is about dimensions. So there are lot many dimension types, but those are not important to us. So we might see few questions on the data warehouse concepts. So let's discuss about measures. So what is a measure? It's a numeric information, right? Tables stores numeric data and foreign keys. Numeric data and foreign keys, those will be the measure tables. So there are multiple measure tables, multiple measure types we have. So for example, so what is the use of this measure? These measures are used to perform type of aggregations, any type of aggregations. So let's discuss about the first one is additive measure. Additive measure. What is additive measure? the measures which gives a meaningful information after performing all type of aggregations. Such measures can be called as additive measures. Got it? So it gives a meaningful output with all the dimensions after applying any type of aggregation. So what type of aggregation functions we have? We have sum is one of the aggregation, average is one of the aggregation, minimum is one of the aggregation, maximum is one of the aggregation, count is one of the aggregation, distinct count is one of the aggregation. Okay, mean is one of the aggregation. So like the way we have n number of aggregations. So if any measure table which any measure table which gives a output meaningful result to dimensions after performing all aggregations will be called as additive measures. So meaningful result means what? For example, you can take sales. Okay, you can perform any type of aggregation on the sales measure. You can perform what is a sum of sale amount. Sum of the sale amount of entire business you can calculate. So sum of sales for a customer you can calculate, for a location you can calculate, for any time period you can calculate. Okay, for any product level you can calculate. Like the way you can perform any type of aggregation whatever specified here. So this is a simple measure which supports for all the aggregations: average, minimum, maximum, count, distinct count, mean. Performs all type of aggregations and it gives a meaningful output used to analyze your metric performances. So that those type of measures are considered as additive measures. Got it? So and the second one is a semi additive measure. What is a semi additive measure? So for example, if any measure which is giving a meaningful output after performing few aggregations, so such type of measures considered as a semi additive measures. Okay, let's take an example. There is a column, this is a customer column, this is a respective day column. Okay, there is a column called account balance. Okay, so the customer having on daily basis what is the amount to balance in his account. This is a such type of table. So when you are performing a aggregation, if you perform on this table, if you are able to perform a customer wise sum of balance. Okay, for example, Prem is a customer. Every day he'll maintain some amount in his account. So if you are summing of all days of the balance in a month, is that a meaningful output to get what is the balance of the customer? It is not meaningful. So the balance is a column storing what is the current balance. If you're summing of 30 days of a balance information, so there is nothing to analyze from that column. So this type of a measure does not fit to perform sum aggregation. Okay, so you can use the similarly You can perform average of the balance, average how much he is maintaining in his account, that you can take it up. Got it? So such type of measures can be called as semi-additive measures. What is semi-additive? The measures which gives a meaningful output, supports to perform only few aggregations. It does not support for all aggregations. It dependent on the measure what you are using. So it is not like sum always cannot be possible to perform sum of aggregation in semi-additive. It's not like that. Based on the measure column what you are utilizing, accordingly that measure column supports for few type of aggregations. It does not support for all aggregations. So those all are the semi-additive measures. And another one is a non-additive measure. Non-additive measure means what? If the measure table which is not derived to meaningful output with any type of aggregation, such type of measures called as a non-additive measures. Got it? The measures does not support for any type of aggregation. Such type of measures can be called as a non-additive. So what we can take, for example, discount is one of the column we have in the database. Okay, so it is storing in the percentage basis, 7.5. Okay, 10.3, something like this. What is the percentage provided to the customer based on the sales? We are using this discount. In the database also it is stored as a percentage basis, but there is no percentage symbol because we have given on percentage basis. Okay, you cannot perform any type of aggregation on this discount percentages because it has a floated values. So you can find out rate card using the discount. So you have to do some transformation to show proper information. Show proper information, you have to do some calculation. So for example, sales is 100, okay, price is 1000. So the discount need to be minus from the 7.5. 7.5 into 1000. This is the final sale amount. Okay, so you cannot perform like what is the sum of discount, what is the average of discount. So average of discount cannot be performed on this percentage column. Okay, because you don't know about the price, you know only the percentage number here. This is one of the example to identify non-additive. So if any measure which is storing the information like any rational information 11 by 23 something like this, those also cannot be considered as a, those also cannot be utilized for any type of aggregations because this information is required to identify rational information but not to calculate for analytical perspective for any type of aggregation, but it can be utilized in the reports. Okay, so such type of measures can be called as a non-additive measures. So these all are the dimensions, and there are three type of measure types. So sometimes they might ask you what type of factor types we have. So this is answer, I mean three type of measures. additive, semi additive, non additive. Okay, so this is about a complete warehouse. So among all of those, what are the important questions? Interview questions. First one is OLTP, OLAP systems. So this is one of the interview question, and they'll ask the question about the schema level, star and snowflake schemas. Okay, and they'll ask you the brief description describing about both the schemas, and also they might ask about that hybrid schema as well. Okay, so what is another one? SCD types. So in which they might ask you about type 1 difference between 2 3, so not more than that. What is SCD, what type of SCD types we have, and the fourth one, measure types, and the fifth one, degenerated dimension. So, and mm, shrunken dimension. Okay, so these are the inter questions we have in data warehouse. So got it. So we already discussed about this, and also we discuss about all the inter questions in the later classes. So then, okay, okay. So like the way we have various type of dimensions and the measures. So as we discussed about various Tableau components, right? Where is that? Okay, leave it. So we have created I mean the products list what we have in the Tableau. Okay, so there are few interview questions as well on those questions also. So what type of interview questions? What type of interview questions? Difference between a Tableau server and online. What is the difference between Tableau server and Tableau online? Okay.
It's a cloud-based online.
Which one?
Prem, I have shared the content on WhatsApp.
Shared in WhatsApp. Okay. No, what do you want? I didn't get you.
No, no, just you asked us right
No,
regarding the
no, 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 no.
content.
Not the content. So I'm talking about interview questions which might ask you the classes what we discussed till now. Okay. So at a Tableau product level, what type of questions we might get? So difference between a Tableau server and Tableau online. What are the differences? We already discussed about this, right? And what is the use of Tableau reader? What is the use of a Tab CMD? Okay. So these all are the interview questions from product level. Okay. So let's discuss about the Tableau desktop. So what is Tableau desktop? This is the developer tool which can be used to establish connection to the data sources. You can do uh, you can perform transformations. Transformation means you can do some cleanup process based on the report need. You can create visualizations. You can manage transformation using the calculated fields. You can achieve the client requirement. So for example, once you install Tableau desktop, how to install Tableau desktop? How many of you installed the Tableau desktop in your machines? Search for Tableau desktop, download, open this, give the details here. So you can provide the dummy details also. Just to mention the details as a student 1 to 20, department IT, analyst India. So you can mention dummy number as well. Then search for, select an option, download a free trial. Let's download this. Okay. So like the way you have to download the Tableau desktop. So hope you guys already installed or yet to install Tableau desktop. Okay, you can search anything for Tableau, like for example, data types in Tableau. Look at help.tableau.com. This is the official site, documentation site. Uh, Documentation site where you can able to see all type of information, product level information in depth here. So this is the official site, help.tableau.com. So for any scenario cases, for example, let me show you one thing. Okay, so this is one of the site where you can see white papers, such information about the Tableau content or Tableau product. Okay, so once you search for anything, you can see this type of sites, help.tableau.com, otherwise tableau.com, some extension with any type of name based on your search. Okay, so there is one more, this is one more site which is from Tableau. This is the official site, kb.tableau.com. So for most of the scenario cases, if they find any resolution officially, they will promote it through knowledgebase.tableau.com. KB means knowledge base, where also you can find your solutions. There are multiple suggestions with the related links. You can able to analyze. So what I'm suggesting, in the future going forward, when you are searching for anything about a Tableau, first get information from these sites, help, knowledge base. Okay, later you can, there are a number of other sites which promotes, which shows other information from various source systems like tutorials point, interworks, what is that, stakeholder, what is, mm. So a number of authors, they'll promote their content, you can utilize from that as well. Okay, so these three are the official sites you can utilize. Then, so once you install Tableau desktop, how to install, once the software is downloaded, just double click on it. Already I have the same version. That is the reason it is asking for repair or uninstall. Otherwise it will it will show an option to install. I'm going with the repair. Yes, sir. Okay, so it's very simple. With the next option we can able to install. If it ask you any details, mail ID, mobile number, you can, for now you can utilize a dummy. Do you have any friends, juniors, relation who is studying a BTech, who is pursuing the BTech or a degree? Get the ID card from them. So it has to show university name. I mean, that might be the college name. Okay, date of birth, not the date of birth. Sorry, uh, tenure period. It's a tenure period. Like if he is a BTech student from 2023 to 2027. So this period must be shown on your, on the ID card. So ask him to get a front and a back, back side of a ID card. Got it? మీ కాంటాక్ట్స్ ఎక్కడ ఎవరు బీటెక్ పర్సూ చేస్తూ ఉంటే వాళ్ళ దగ్గర జస్ట్ ఒక ఐడి తీసుకోండి. ఇక మీ దగ్గర ఏది లేదంటే జస్ట్ లెట్ మీ నో, జస్ట్ మెసేజ్ మీ ఇన్ ద వాట్సాప్, ఐల్ చెక్ ఇట్ అవుట్ అండ్ ఐల్ గెట్ వన్ ఐడి కార్డ్. so that we will get a product key which can be used for 1 year license. Okay, so like the way you can able to install Tableau desktop.